In our day-to-day life, we come across different situations to use integers like profit or loss in a transaction, height of a tree, depth of a river, temperature of places above and below 0 degrees Celsius, etc. The first numbers to be discovered were natural numbers. That is 1, 2, 3, 4 and so on. If we include 0 to the collection of natural numbers, we get a new collection of numbers known as whole numbers. That is 0, 1, 2, 3, 4, etc. Now we find that there are negative numbers too. If we put the whole numbers and the negative numbers together, the new collection of numbers will look like 0, 1, 2, 3, 4, 5 and so on, coming to -1, -2, -3, -4, -5, etc. And this collection of numbers is known as integers. Integers are useful in comparing a direction associated with certain events. In this chapter, we will study about integers, the number line, opposites, absolute value of an integer, addition and subtraction of integers, and exponents. Integers. Integers are the set of whole numbers and their opposites. The number line can be used to represent the set of integers. Look at the number line. Positive integers are all the whole numbers greater than 0. 1, 2, 3, 4, etc. Negative integers are all the opposites of these whole numbers. -1, -2, -3, -4 and so on. We do not consider 0 to be positive or negative number. For each positive integer, there is a negative, and these integers are called opposites. For example, -3 is the opposite of 3. -21 is the opposite of 21. And 8 is the opposite of -8. If an integer is greater than 0, its sign is positive, plus. If an integer is less than 0, its sign is negative, minus. The number 4 steps forward from 0 is written as +4, read as +4, and the number 3 steps backward from 0 is written as -3, read as -3. The number line. The number line is a line labeled with the integers in increasing order from left to right that extends in both directions. For any two different places on the number line, the integer on the right is greater than the integer on the left. For the counting numbers, each number is one more than the one on its left and is one less than the positive integer to its right. So, for integers, forward is increasing. The more to the right, the greater the integer. Example, +3 is to the right of +2. Therefore, +3 is greater than +2. Positive 7 is to the right of positive 4. Therefore, positive 7 is greater than positive 4. For negative integer, the more to the left, the smaller the integer. Example: negative 4 is to the left of negative 2. Therefore, negative 4 is lesser than negative 2. Or negative 2 is greater than negative 4. Negative 1 is to the right of negative 2. Therefore, negative 1 is greater than negative 2, or negative 2 is lesser than negative 1. So, for all integers, the more to the right, the greater the integer. Example: negative 1 is to the right of negative 5. Therefore, negative 1 is greater than negative 5. Positive 2 is to the right of negative 7. Therefore, positive 2 is greater than negative 7. 0 is to the right of negative 4. Therefore, 0 is greater than negative 4. Note, a positive integer does not have to have a positive sign on it. For example, positive 3 and 3 are interchangeable. A positive integer may be written with or without a sign. Opposites. Two integers are opposites if they are each the same distance away from 0, but on opposite sides of the number line. One will have a positive sign, the other a negative sign. In the number line, positive 3 and negative 3 are labeled as opposites. Absolute value of an integer. The absolute value of an integer is its numerical value regardless of its sign. Example: the absolute value of negative 8 is 8. The absolute value of positive 4 is 4, and so on. To represent the absolute value of an integer, write the integer between two vertical lines. Thus, absolute value of negative 8 equals 8. Absolute value of 4 equals 4, and so on. Therefore, if a represents an integer, its absolute value is represented by and is always non-negative addition of integers when the integers have like signs. When the integers have like signs, that is, when both the integers to be added are either positive or are negative, add their absolute values and assign the same sign to the sum. Example: add positive 3 and positive 2. Here, both the integers to be added are positive, and positive 3 plus positive 2, which is positive 5. Add positive 57 and positive 112. Here, both the integers to be added are positive, and their absolute values are 57 and 112 respectively. First, find the sum of absolute values of positive 57 and positive 112. The sum of their absolute values equals 57 plus 112 equals 169. Therefore, positive 57 plus positive 112 equals positive 169. Add negative 32 and negative 83. Here, both the numbers to be added are negative and their absolute values are 32 and 83 respectively. Then add the absolute values. The sum of their absolute values equals 32 plus 83, which equals 115. Therefore, negative 32 plus negative 83 equals negative 115 when integers have unlike signs. When the integers have unlike signs, that is, one is positive and the other is negative. Determine the difference of their absolute values and assign the sign of integer of greater absolute value. Example, add positive 53 and negative 29. The absolute values of positive 53 and negative 29 are 53 and 29 respectively. Then find the difference of these absolute values. Therefore, their difference equals 53 minus 29 equals 24. Since the integer with greater absolute value is 53 and its sign is positive, positive 53 plus negative 29 equals positive 24. Add negative 53 and positive 29. The difference of absolute values is 53 minus 29 equals 24, since the integer with greater absolute value is 53 and its sign is negative. Therefore, negative 53 plus positive 29 equals negative 24. Subtraction of integers. To subtract two integers, change the sign of the integer to be subtracted and then add. Example, subtract positive 5 from positive 8. To subtract positive 8 minus positive 5, first change the sign of the integer to be subtracted. That is, positive 5 changes to negative 5. Then add positive 8 and negative 5. We get positive 3. Subtract negative 5 from positive 8. To subtract positive 8 minus negative 5, first change the sign of the integer to be subtracted. That is, negative 5 changes to positive 5. Then add positive 8 and positive 5. We get positive 13. Subtract positive 5 from negative 8. To subtract negative 8 minus positive 5, first change the sign of the integer to be subtracted. That is, positive 5 changes to negative 5. Then add negative 8 and negative 5. We get negative 13. Subtract negative 5 from negative 8. To subtract negative 8 minus negative 5, first change the sign of the integer to be subtracted. That is, negative 5 changes to positive 5. Then add negative 8 and positive 5. We get negative 3. Exponents. Exponents are shorthand for multiplication. The word exponent stands for how many times the thing is being multiplied. The number being multiplied is called the base. The process of using exponent is called raising to a power. where the exponent is the power. 5 raised to 3 is read as 5 raised to the power of 3 or the third power of 5. 5 raised to 3 is called exponential notation for product 5 multiplied by 5 multiplied by 5. Here 5 is called base and 3 is called exponent or index or power. Example, in 2 raised to 3, base equals 2 and exponent equals 3. Note, for any number a raised to 0 equals 1. Anything to the power 0 is just 1. Example, 2 raised to the power of 0 equals 1. 5 raised to 0 equals 1. For any number a raised to 1 equals a. Example, 2 raised to 1 equals 2. 5 raised to 1 equals 5. Some rules about exponents. Rule 1. Whenever we multiply two terms with the same base, we can add the exponents. X raised to m multiplied by x raised to n equals x raised to n plus n. Example, 2 raised to 3 multiplied by 2 raised to 2 equals 2 into 2 into 2 into 2 into 2 equals 2 raised to 3 plus 2, which is 2 raised to 5. Note that we cannot simplify 2 raised to 3 multiplied by 3 raised to 2 because the bases are different. Rule 2. Whenever we divide two terms with the same base, we can subtract the exponents. X raised to m divided by x raised to n equals x raised to m minus n. Example, 2 raised to 6 divided by 2 raised to 2 equals 2 into 2 into 2 into 2 into 2 into 2 divided by 2 into 2 equals 2 raised to 6 minus 2, which equals 2 raised to 4.